Welcome to Learning Curve, the podcast where we explore how companies can harness emerging technologies to drive real business impact without the buzzwords and hand waving. I'm Matt Sharp, AI strategist, code whisperer, and occasional pinball wizard.
A nod to the Who, huh?
Yes.
And I'm Holly Fake, UX designer, researcher, and your guide to decoding the human side of tech. Whether you're joining us for the first time or you've been riding shotgun since day one, we're glad you're here. Our goal to give you an unfiltered behind the scenes look at what bringing on an AI lead actually entails. We mean the triumphs, the awkward missteps, and yes, even the command line sorcery wrapped in zip ties. Last episode, we caught up with Bryce Ruth to break down what onboarding an AI lead actually looks like. What we discovered, well, real success means embedding an AI expert into your leadership culture from the ground up. Today, we are thrilled to be joined by Melinda George. She's one of Flexion's sharpest and most thoughtful engineers. She's not just building tools, she's helping fix Medicare for 65 million Americans. And she's also been working with Matt to bring AI into a pretty surprising place, a legacy COBOL system. Melinda, can you tell us a little bit more about yourself?
Thanks, Ollie. I've been in software development for almost 30 years, and I started out as a COBOL programmer during the Y2K. Since then, I've moved into more modern tech stacks, but most of my career has still been spent helping to modernize legacy systems in one way or another. I've always been big on quality, and I'm naturally curious and a little bit skeptical too, but I'm really interested in how we can make sense of all of this the change that's coming about with AI coming into our industry.
And I know that's true that how curious you are since I work with you on the MCADS project. If you're curious about how exactly you bring machine learning into a system that predates the internet, buckle up. We've got a story for you. So now let's rewind a bit. What was Flexion's history in modernizing COBOL, and why was this a good project for us to focus on?
For me, over the last 5 years, I've worked on two big legacy modernization projects at Flexion. The first was processing millions of records in AWS batch and bringing, faster, more accurate processing and modernizing the mainframe processing of those claims, but needing to be able to compare and process those at the end, the inputs and the outputs needed to exactly match the mainframe. The second project was more about real-time claims adjudication, which is the project that I'm on right now. It's a totally different problem, but the same goals. We need to have, full confidence that we are matching the mainframe output byte by byte. With that, Flexion learned a lot in both that first project and everything we've been doing on the project I'm on now. But we want to see how we can use AI um, to leverage all of the human things we did. We didn't have that in the early days of these projects, and maybe go faster with more quality, analyzing the data. And at the end, if we can do that, and if we can, with fewer and fewer COBOL developers in the industry, if we can do that, it could be a huge win for future work for Flexion as well.
So tell me, where does AI fit into this picture?
Yeah, so as Melinda just said, there's fewer and fewer COBOL programmers. So, which is kind of a scary thing when you realize, a lot of the government, a lot of banks, a lot of the world runs on COBOL. And that's a problem because it makes it hard to upgrade these systems. It makes it hard to add new features. It makes it hard to, move forward. So as Flexion has done these modernization projects, it's a lot of work with fewer and fewer people able to do it. And so we were hoping, AI has shown a amazing ability to do translations. Modern AI is really good at going from like English to French or German to um, Ukrainian or whatever it is. And so we're like, and it's also been able to show pretty good results translating from maybe one program to another, maybe JavaScript to Python. So we want to take that same idea and say, hey, can it help us go from COBOL to something modern like Java? The you know, However, the problem is, and I didn't know much about COBOL, but like it's COBOL is nothing like Java. So what we first wanted to do was say, hey, can we at least just go from COBOL to English, a natural language that we could understand and we could start to work more with it. Because if we could get to natural language, then we can get through the bottleneck of not having a lot of COBOL programmers and get straight into the hard work of, having more experienced software devs that know Java or Python or these modern languages and start making the transition from the English explanations of what the program is doing.
That's really interesting. So you thought of the LLMs as a mechanism or AI as a mechanism to be a translator and thinking about it by turning COBOL into not necessarily Java, but like into English. And so then that makes me curious. It sounds like you shared a little bit about your experience with COBOL, and it didn't sound like you have a lot. But Melinda, can you tell us a little bit about your experience with COBOL, which I know you've touched on before, but a little bit about your experience with AI too?
Yeah, I mean, back when a long time ago, I remember, code generators and things like that and the mainframe, that was going to be the thing of the future. And I had never developed an affinity to those. They just never won my trust whatsoever. They developed junky code that wasn't maintainable. So I come to it with like a pretty healthy, maybe too healthy skepticism with needing to know how this all works, needing to find a way to trust the process with my quality background, so that we can, really, really get to a point where we can move forward and like use this in meaningful ways. And I think that, before this, my AI experience was, Chat GPT, writing, summarizing meeting notes or writing up text for something that I was trying to do, but nothing, maybe a little bit of Copilot and things like that. But it's really, all of that has been developing pretty quickly. Um, During this, I think we were trying to figure out with that skepticism, how did we take something that I understood really well and, process it in a way that other people, everybody always said like human readable, although I am human, that would be more human readable for people to, in the end product owners, business owners, things like that.
Yeah, I mean, if Melinda had not a lot of experience with AI, I definitely had much less experience with COBOL. And there was a lot of learnings that had to be done to be able to get AI to work in this pretty niche space. COBOL, it's just a kind of different domain than other languages. It and a large part of that comes because of the natural constraints of the language, especially when it came, because when COBOL was a popular language, computers didn't have a lot of memory. And that is reflected a lot in the language, both in the variables the programmers chose, that which are often condensed and not very much English, but also in, the function names and everything that goes with it. You had to kind of compress everything back in the day and make it all fit. And the code is also designed to like run on mainframes. It wasn't ever designed to run on your laptop. And so all of these kind of lead the language to be a little bit different. And I found it very fascinating working with COBOL, and it led to some surprising results as we did this, AI proof of concept working on this.
Yeah, you mentioned some learnings and then now the proof of concept. Can you tell me a little bit about what we did?
Yeah, so the proof of concept, um, it was a relatively short period, but it was getting our feet wet and trying to really understand the space. And so what we started by, in order to do this, was essentially we created this evaluation data set of of, hey, uh, kind of taking a bunch of COBOL and taking it to English translations, and then just seeing, hey, which models are good or bad at this? So we actually evaluated probably a dozen different models, really kind of looking for different patterns and, hey, which models are good or bad at this task? And that was kind of one of the main learnings of the task. And then we went and we took the best model from that group and we tried to take some of the code that we had and see how it performed as far as creating human understandable translations of that COBOL code.
Melinda, what was your experience on the proof of concept?
Yeah, I mean, I didn't really know what to think coming in. I had worked a little bit on something prior where we were thinking like, well, what LLMs would we want to evaluate? And had a few opinions and curiosities around that. But I also treated the whole idea of this POC a little bit like a genie in a bottle that I was gonna, that we were gonna train an LLM. I had a lot of things to learn, I guess, about sort of that we wouldn't be doing any training, that was a more complicated thing, that um, a lot of the terminology and type things like that. Um, but basically, just lots of questions, sort of trying to satisfy my curiosity, but also like just distill how this was all going to work. And one of the things that I remember is that Matt kept, saying we need a data set to train to, sorry, Matt, to, what's the word again?
To evaluate.
Evaluate the evaluation data set. There you go. See, I've forgotten already. The evaluation data set that we're going to use is really, really important. And I was like, yeah, that one that you found on the internet, that looks good. Let's start. I want to get going. I want to figure some things out. I mean, we did look at it. I'm not gonna say we didn't look at it, but I didn't fully understand at that point in time how important that would be until later on in the process and things like that. The training um and sort of the parts of the system that I just treated like um that AI could either do way more than it could, kind of like a Star Trek, could beam me in anything I wanted, um, to just sort of being a little bit too skeptical of what it might be trying to do that wasn't something that it was trained for, essentially. So.
You mentioned how important that data set was. Were there other things that you learned in the process of evaluating these 12 different LLMs?
Yeah, I would say there were some patterns in the LLMs that were very interesting. So when we were doing this, like we specifically chose very intentionally different models we wanted. So we compared against, some of the state-of-the-art API models, like Anthropic's Claude, OpenAI's, GPT, 4.0, the best at the time that we could get. We also compared it against several different open source models. So we found some open source models that were actually fine-tuned on COBOL already. We found, just some general good ones. So some reasoning models versus some instruction models, as well as, different sizes. So from smaller models to larger models of the same type, some llama models we were comparing, as well as some that were just like trained on coding problems. And so we were kind of looking for like, is there any patterns? And there was some interesting aspects. For example, the latest state-of-the-art models, like the newer the model was, the worse it was at the task, which is a bit surprising. You generally think the state of the art is always going to be the best at your specific task, especially they tend to be bigger, they tend to be trained on more data, but they were worse at our specific task. And there's lots of reasons why this could be. Maybe it's because a good chance is because these state of the art models are trying to beat these like you know, benchmarks like Arches 2 or, like these really complicated problems. And so they're going after a different direction than trying to understand archaic or older languages, or programming languages that people don't use anymore, like COBOL, right? Like that is just something that these big tech firms training these latest models don't care about. And so it was actually the older models that did better at it. And so that was one interesting fact. Other some y- like that wasn't expected. One that was expected was actually we found that models that were trained on code, not necessarily COBOL, but like a lot of other, Python, JavaScript, etc., like coding models like Star Coder, they were actually really good at the task. And so there were some things that were expected and other things that were surprising. So it was very fun to kind of see how like uh this arena of these different models did on our test set.
Yeah, and it's interesting because the code is, 40 or 50 years old in some cases. Some of the code we were trying to use to then use the evaluation set to then parse through this 40 some year old code and determine what it was doing, what are the business requirements that it's trying to satisfy, what's the overall big picture of what this code is trying to do. And so it's not only that it's a different it's a different kind of legacy code, like Matt was saying, but it's also that it's been maintained for 40 years. It's going to be by the very nature of any code, it's going to be older. And then on the mainframe, you have less testability, you have more patching in of bugs versus like actual structured architecture and things like that, in my experience, when you're looking at mainframe legacy code. So, yeah, it was
So when
interesting.
you're getting the English back, is it the kind of you're almost even having to parse what it's coming back with, given that there's patches and bugs, like you said?
Yeah, you really had to like look at you were trying to yourself parse through as a former COBOL programmer, what was this program actually doing? Because it's not pretty. And then you're also looking at its take on it. And sometimes it would, hallucinate or go down a track that you weren't really expecting. Maybe big picture it a little bit. But yeah, I don't know. What do you think, Matt?
Yeah, I think well there were kind of a lot of different aspects of it because what we were originally doing is we were saying, okay, translate this COBOL to English, but also like summarize it at the same time so that way you could quickly understand it. But those are kind of two different tasks. And so that was one of the things we wanted to look at is would it be better if we first translate it to English and let it be as long as it could. And, COBOL programs, what I found out can be very, very long, often, 75,000 lines or longer. And so it's just like, maybe we just need to translate it, and have, 75 pages of English explaining it and then summarize it, right? And so there were definitely kind of some aspects of, okay, like this problem has lots of complexity to it. How can we, which means there's multiple paths and multiple different ways to try to solve the problem. And so part of this was trying to understand, okay, which path seems to make the most sense right now with what we're doing. And yeah, it was interesting for sure.
Yeah, and continuing that thought, you both have worked in traditional development environments before. How did let's talk more about how this AI infused process compared.
Yeah, I mean, I've done quite a bit of AI development before, so a lot of it was what was pretty new to me. What I would say is this was kind of one of my first Flexion projects. So uh, it was very interesting because we pulled in a bunch of people. It wasn't just me and Melinda. It was a team from different aspects of the company, and we're all coming together to try to bring in different experts into the room. And it was just a very interesting approach to how Flexion really kind of attacks and solves problems. And there were some aspects of like collaborative coding and just like user-centered design and everyone, you know, agile frameworks, everyone was bringing in their expertise and we were able to utilize all of them to be able to quickly, smoothly, and efficiently like kind of learn a lot really quickly. And that was a lot of fun to see for me.
What's your take, Melinda?
Yeah, I was gonna say like the same that I enjoyed the collaboration. I do enjoy in these types of things being able to collaborate with people across Flexion that I wouldn't normally get to collaborate with on my team every day. So that was interesting. We basically are still collaborating, iterating, looking at a feedback loop of what did we learn from this cycle of trying something and then figuring out what we needed to learn or do next. But basically, you're still testing and things like that. The thing that was different for me is that in traditional code, it's very mathematically exact what you put in and what you get out. You can write exhaustive unit tests for your code and you know exactly what it's going to do when you're done. And AI still to me just seems a little bit more less exact than that, but that you're guiding the AI's behavior. You can't exactly predict. There's, almost literally no way that you can predict the outcomes. You're just sort of trying to get it closer to what you're looking for from it. So I found that really interesting.
You've described it in so many fun ways, like a genie in the bottle, a mystery black box. If there are folks listening who are gearing up for their first AI project, what would you tell them and what do you wish somebody had told you?
I'd say you'd have to like come in curious, but stay skeptical and, really try to dig in and figure things out. There's just a lot that AI can do and that we can learn from AI, that we can go faster and, freeing yourself up from some of the the shackles of there aren't enough people that can read this COBOL code. So getting more competency around that, for example, we'd um, be able to do more of the kind of work that is that's sort of the next level of that, basically modernizing that system more quickly and how it can help us. But you need to really you know, have an idea of what you're looking for. You have to be able to test it. I think it really makes a huge difference to know what you're doing and separating that what from the how, but it then releases you from like how you're going to do something a little bit because the AI starts to take that over a little bit once you can trust it, I guess.
Matt, anything you'd add to that?
No, I thought that was great.
So here's what we're walking away with. Proof of concepts are great. You can get your hands dirty and you can learn the ins and outs of AI. If you come prepared with a great data set, that's going to help you out a lot. There's a lot of math and statistics that are going to influence your results. Good data in, good data out. And if you're starting your own AI journey, start scrappy, stay curious, and get building.
Well, that's a wrap for today's episode of Learning Curve. If you enjoyed this conversation, do us a favor, subscribe, share it with your team, and maybe even that one exec who keeps forwarding you AI thought leader articles.
And don't miss our next episode. We'll be diving even deeper into the guts of the AI projects we've launched. Real tools, real results, and real lessons learned. It's going to be a good one.
Until then, I'm Matt Sharp.
I'm Holly Fake. Thanks for tuning in to Learning Curve. Keep experimenting, keep asking better questions, and we'll see you next time.